All right, I'm super excited to have all of you guys today. We are going to be talking about DB/SQL AI functions. I hope you can learn a lot through this session. This session is going to be presented by me. I'm Sid. I also have Youngbin with me, who will be joining in for the second half of the session to walk you through a demo, show like the cool stuff, and in the end, we'll be talking about like the roadmap, what you can expect from the space in the future. We would love to sort of like connect with you after the session to learn what your needs are, to learn what your experience has been if you're using AI functions today. So please do connect with us after the session. All right, standard information. All right, so you know Databricks has been a leader in data analytics for more than a decade. And all throughout that time, we have invested deeply in AI through company acquisitions like Mosaic or Fennel, or even striking strategic partnerships with, for example, the one that we did with Anthropic earlier this year. These deep investments in AI have helped us to build very successful customer offerings across ML Flow, to AI Builder, to doing feature engineering, to doing model serving, and so on and so forth. So within this cloud of like great technology, we have this data warehouse, DB/SQL product, which is amazingly successful. It is used by more than 60% of Fortune 500 companies. So as data warehousing or DB/SQL owners, we looked at our users and we wanted to figure out what did our users really want. And we heard it loud and clear that they wanted to use AI. But we found that they were struggling to use AI within their SQL workflows. Obviously, calling custom models, custom model endpoints is hard. If you have your own model that you want to serve, even figuring out how to serve it is hard. And then on top of that, you have to deal with things like errors, rate limiting, and then figure out how to sort of like provision your pipelines, provision your model endpoints to get like the right performance and to get your workflow working. We wanted to simplify this dramatically, and we did so by integrating an easy-to-use, almost self-managed set of AI functions that you could just invoke like any other SQL function from DB/SQL, and that is DB/SQL AI. So you might have seen this presentation last year as well. We've been working on it for a year and a half now. Over the course of last 1.5 years, we've brought you a framework that is embedded within DB/SQL, and that makes tasks such as classification, analysis, sentiment analysis, data masking, even doing forecasting of your time series data, a very, very simple and easy to task. All you need to do is invoke one of these functions. So these are a set of fully managed functions that just work out of the box for you and let you focus on solving your use case using AI rather than trying to figure out how to make AI work for your use case, which is the thing that we wanted to aim for. So we have a lot of like great functionality that is packed into this box. This is used today by some of the largest customers in Databricks. But it's not just the capabilities that power this entire framework. We also have a backend engine that basically powers the entire framework and gives you all of these capabilities at scale. So firstly, you get access to ready-to-use models through these managed functions that are directly integrated into the SQL syntax. So you don't have to worry about how do I bring my model, what model I should use. You just call the function and we take care of the rest, right? If you want, you do get access to a lot of state-of-the-art models that are spread across Databricks foundational model API and also external models like OpenAI, GPT. It's your choice, right? So we give you the flexibility, but if you don't want to deal with all of that, we also give you like a full set of managed functions that you can just use to get your work done. Apart from this, the engine lets you focus on your use cases, and all the ML engineering that went into this engine handles everything related to infrastructure, tuning, fitting, scaling your pipeline, right? You don't have to worry about any of that. And the system also auto-scales. So as your use cases grow, as your business grows, we will automatically sort of like auto-scale this entire stack so that you get the right performance and the right TCO for your use cases. So to dive a little bit deeper, we have basically two classes of function that are built into this AI functions framework. So the first category of functions is what we call as classic ML. These are essentially functions that are not backed by LLMs. So in classic ML, we provide functions such as out-of-the-box, fully managed forecasting functions that let you forecast your time series data into the future. So if, let's say, you have sales data, you can try to run forecasting over your sales data. It will automatically train over the time series data, and you can ask it questions like, what will my sales look like in the month of July and August, right? And it should be able to answer that. Similarly, we also allow you to leverage vector search indices to perform state-of-the-art KNN searches to group your data into similar sets. The second suite of functions are these prepackaged and self-managed LLM functions. With these functions, you don't have to worry about what the model backends are and how to query those models. You can focus on the functionality you need. For example, if you want to do sentiment analysis, you can just focus on that. Or if you want to generate summaries of your data or translate from one language to the other, all you need to do is just invoke these functions. What models get used, how these models work, how we talk to the endpoints, that is all taken care of you behind these functions. Having said that, we also understand that the previous set of LLM functions and even classic ML functions may not suffice for all your use cases, right? For that reason, we've built a very powerful function in DB SQL AI, which is called AI Query. This is a very generalized, flexible, but parameterized function that allows you to query ML models across both the foundational model set of APIs that are available, but also external models such as GPT. This function allows you to talk to your LLM models and get your custom use cases solved while allowing you to alter tuned response and request interpretation that we send to the models. So it's not just the flexibility of this model, of the function that is powerful. You can also use this function in various ways in DB SQL, right? So combining like the power of DB SQL, for example, you can use this function to filter out your data. So the example on your left is basically taking sentiments from customer reviews, and it is trying to only print sentiments that are positive, right? You could have done that with negative sentiments as well. On the right, we have an example where we're taking all of the reviews in aggregate, and we're trying to sort of like get a feel factor for where are my reviews trending, right? Is this like generally positive? Is it mixed? Or is it generally negative? So with a combination of all the DB SQL flexibility and the flexibility of AI query, you can do all of these powerful use cases and many, many more, right? So with all of these AI functions in DB SQL, you can easily integrate AI into your application workflows. You can use these out-of-box self-managed AI functions that take away all of the work around LLM infra setup and workload tuning. And our customers love this, right? This is an example, a quote from a customer who's talking about like the self-managed nature of the framework and how it is accelerating their business. This is another quote, from another customer who's talking about like the scale that they're able to achieve with these self-managed AI functions. So this was all great, right? But this was all in the past, right? What's new this year? So this year, we have turbocharged DB SQL AI. The framework is backed by a powerful new engine called batch inference, which reduces your workload processing time from hours to minutes. These set of AI functions on this new engine is 10x faster, sometimes even up to 100x faster than the previous version. And across like all of the industry performance benchmarks, we are 3x more powerful or faster and performant than any other AI suite of functions that exist out there. And performance is not the only thing that we focused on. Deep SQL AI now also supports multimodality. So with AI query, you can now perform image classification, image extraction, and many other analyses right from SQL, right? So the example at the bottom shows us asking about, describing what this picture is, and the model responds back. It may not be readable, but it responds back that this is like a grassy field with like a boardwalk in between. So you can do a lot of like very powerful stuff on it. In addition to that, we are very excited to announce AI Parse Document. This is a very powerful and multi-purpose interface to extract insights, tables, charts from your documents. So if you have unstructured data sitting in PDFs and docs and docx, you can use this function to be able to extract like all the insights that you wanted to extract. Again, this function is like very simple to use, fully managed behind the scenes, uses the foundational model API, it's scalable, performant, and it supports a broad range of document types. We've also added support for many new models. For the first time, the Claude set of family of models are available through the foundational model API. The foundational model API now also supports Llama 4 Maverick. And as before, all your favorite models are also available directly, which are queryable through the external model endpoints. And then there are many, many more capabilities that we've added to enhance your experience with AI functions in DB SQL. So one of them is we've added support for reasoning models. These are basically multi-step reasoning models. So now you can actually invoke them with an AI query and get like much more accurate and well thought of response. We've added capabilities for structured output. So you can actually tell the model how you would want to see your output, like in a JSON format and all. And we found that this greatly sort of like improves the quality of results that you see returned back from the LLMs. And we've doubled down on reliability. So we've added much more better observability right in the dashboards that are visible to you, better error reporting. We've added support for fail on error. So all of this ensures that you can sort of like manage your production workloads with ease on these LLM functions. So in all, through the introduction of unstructured processing and multimodality, coupled with better performance and improved reliability, you can generate rich insights across all your data, whether your data is sitting in a structured format in the form of tables, or it is sitting in a PDF or an image. You can now extract information from both of these sources, combine them to generate insights to solve your business use case. Now, to show you some of this functionality in action, let me invite Youngbin on stage, who will walk you through a demo. Thank you.
So now that we have seen what AI functions are, let me show you a complete example. And here's what we are building: an interactive dashboard that analyzes 11,000 Amazon laptop reviews using only AI functions. At the top, we have filters for brand and products, and this controls everything below. And right below the filters, we have counters showing the number of reviews by sentiment. Oh, it's lagging. And in the middle is feature analysis. And this bar chart here shows sentiment for specific features, like battery, display, and performance. And when I click on negative battery reviews, the table on the right shows only battery complaints. And here I see comments like, battery will die after 2 hours, and battery doesn't charge. And at the bottom is image search. And when I search for blue screens, for example, we get reviews with images showing blue screen problems. And search for cracks, we see physical damage. And here's how this works. Multimodal AI looks at customer images and creates descriptions. And these descriptions feed into a vector search index. When I type keywords in the dashboard, it performs semantic search on that index, returning images semantically similar to my search keywords. Now, let's build this step by step. And we will start by testing our approach in a SQL notebook. And first, we will hide brand names using AI mask for the demo purpose. Let's run it on 10 sample instances. And great, you can see mask where brand names used to be in the review text. Let me create a temporary view so I can use it for subsequent steps. Next, sentiment analysis. We will use AI analyze sentiment on these reviews. Let's run it. And we seem to have reasonable results. Now, feature analysis. This finds what customers say about specific parts, like battery or display. And here we use AI extract with detailed descriptions for better accuracy. Now, we will also get sentiment for each feature comment. And for this, we need to first unpack the struct result using the lateral view, explode, and JSON functions. Then we can apply AI analyze sentiment to each feature comment. Let's run it. Okay, let's look at this example. This review says if you want to use it everywhere, not always in the desk, this laptop is for you. And then if you look at the column on the right, AI correctly found that as a comment about portability. Same for great performance, looks nice, and battery dies when turned off. It got performance, design, and battery right. And for each feature and comment pair, we got correct sentiments, negative for battery and positive for performance, design, and portability. So we now have sentiment for specific features, not just overall reviews. And this looks great. It's now time to run it on all 11,000 reviews. Okay, so let's remove the limit 10 and apply these functions to the full data set and save results into tables. We could also use Delta Live tables for incremental updates or complex pipeline management. Yeah, let's fast forward a bit. Right, now let's build a dashboard. I will create a new dashboard, go to Data tab, and add tables we just created. And then I'll add a counter for the total number of reviews. And let me clone this and add a filter for positive reviews. And I'll do the same for negative sentiments and other ones as well. And for feature analysis, I'm adding a bar chart for sentiment by features. I will also add a table with feature comments. And let's verify clicking bars update the table as expected. Now, I will add filters for brand and products and check that it works. Now, let's work with images. First, we will use read files function to get images from Unity catalog volume. And we will join this with sentiment data, focusing on negative reviews to find problems in images. Now, let's add AI query. We will ask AI query to analyze product images for problems. I will set the response format to get structured output with severity and description fields. And importantly, we use files parameter to provide the image as an input to AI query. And great, you can see how it finds defects in images. This is very useful for quality control, customer service, support, and other use cases. Let's run this on all images in the data set. And fast forwarding a bit. Now, we could use this table directly, but for better search, let's use vector index. This helps us find similar problems even when they are described in different ways. And to keep the demo simple, here's one I prepared earlier using our image analysis results. Back in the dashboard, I will add the image search section. And to do that, I will create a query using vector search SQL command on our vector search index. And add the keyword as a parameter. Let's go back to Canvas and add a table that shows vector search results. And let's also add a filter for the keyword parameter. Now, users can search images by typing keywords. Blue screen finds blue screen images. And cracks shows physical damage. So this combines vector search with multimodal AI for powerful analysis tools. And that's it, a complete analytics pipeline built with AI functions from text analysis to image processing, all using simple SQL queries. All right, next, I want to talk about what's coming up. First, we are doubling down on unstructured data. We will have more features for deeper insights from documents and other data types, such as audio. And second, we will introduce serverless CPU inference. This means users don't need to set up model-serving endpoints for inference. You can just write your SQL query and let the AI functions handle the rest. We will also bring more traditional machine learning features directly into SQL, making it easy to get insights from your data using classic models such as linear regression, random forest, logistic regressions, and so on. And finally, batch vector search. We will introduce scalable vector operation for large data sets. Okay, so if you are interested in these upcoming features or have any feedbacks about existing features, please share your use case and connect with us using this QR code. That's it. Thank you.